Hi everyone, this is Mrs. GA, and today we are going to learn about polar coordinates. So up until now, we've been using a type of coordinate system called a Cartesian coordinate. So you might not have even known that there are other types of coordinate systems because we've only been working with this one type, and it looks like this. So we have our x and y axis, and we all know that the x-axis represents a horizontal movement and the y-axis represents a vertical movement. So another type of coordinate system is called a polar coordinate system. So rather than measuring a point based on horizontal and vertical movement, in a polar coordinate system, the coordinates are defined by the distance from what we would call the origin and by the angle created from what we call the polar axis. So on a polar system, you still will have a value and then a value, but instead of being x, y, the first value represents r, which is essentially like the radius from the center to the point. And then the second value is theta, so it's this angle. So whatever the angle is measured from the polar axis. So it's possible for the angle to be positive or negative, but we measure it just like in the unit circle. We start here at what we call the polar axis. So it's length and angle. Okay, so first we're going to practice plotting some polar coordinates. So here we actually have a new axis. This is a polar axis, so it looks a little bit different than our Cartesian axis. So notice that instead of having horizontal and vertical grids, we actually have like a grid made by successive circles. So each circle represents one unit of your radius, or that r value. So that's 1 unit from the center of our graph. And then you'll see that we also have some common angles drawn out around. So it's also common to see some that have maybe like the 15-degree angles in addition to these. But again, each little circle just represents 1 unit of your length. So if I want to start by plotting the point 1, 3 pi over 4. So first I'm going to start by, I'm going to figure out where this angle is. So remember 3 pi over 4 is right here, 135. And then 1 means I just go 1 unit out from the circle, or from the center, and that would be right here. So it's a little bit hard to see because it's pretty close, but this value is A. Okay, let's try the next one. 7, negative pi over 6. So we know negative pi over 6 is actually here. It's coterminal with 330 degrees. And this tells me to count 7 units out from the center. So I would count 1, 2, 3, 4, 5, 6, 7. And that's where my coordinate will be. So that's 7, negative pi over 6. This next coordinate, 4, 3 pi. So we know that 3 pi is coterminal with pi. So we could actually write this coordinate as 4 pi and we would get the same exact coordinate. So pi is 180 degrees and then we count 4 units out and that is where our coordinate will fall. So this is point C. Now this last one is a little bit tricky because here we have a negative r value. So whenever you see a negative r value, what it means is that you actually head in the opposite direction as the angle that is listed. So you're essentially going 180 degrees opposite. So first let's start by finding pi over 3. Pi over 3 is 60 degrees. But instead of counting 5 going forward, I'll actually count 5 going backwards. So I'm actually going to be traveling along 240 degrees or 4 pi over 3. So another way you could write this coordinate is positive 5, 4 pi over 3. So again, a negative r value just tells you to move in the opposite direction of the angle that's listed. Here's pi over 3, so I'm going to move 5 units exactly opposite that direction. So 1, 2, 3, 4, 5. So here's my coordinate. And there you have it. Okay, so now knowing what we know about how to plot our coordinates, let's see if we can find other coordinates that have the same position as the coordinate 2 pi over 3. So first let's see if we can find 2 other coordinates that have a positive r value that are the same. So essentially, we just need to find a coterminal angle to 2 pi over 3. So we find a coterminal angle by simply adding or subtracting 2 pi. So if I add 6 pi over 3, which is like adding 2 pi, we get 8 pi over 3. So one coordinate that would be in the exact same place is 2, 8 pi over 3. I could also find a coterminal angle heading in the negative direction, giving us negative 4 pi over 3. So 2, negative 4 pi over 3 falls in exactly the same spot. Now, if I want to find two other coordinates that have a negative r value, maybe we can sketch a little graph to help make our job a little bit easier. So 2 pi over 3 would be right here in quadrant 2. And remember, we want to go in the exact opposite direction, and the exact opposite of 2 pi over 3 is 5 pi over 3. And you can also get that just by simply adding pi. So one coordinate that would work would be negative 2, 5 pi over 3, because if I start at 5 pi over 3, but I head in the negative direction, that brings me where we would like to go. And then we could also say 5 pi over 3 is the same as negative pi over 3. So we could say negative 2, negative pi over 3 as well. Again, although the angle here, the angles that we're listing are in quadrant 4, since we're moving in the opposite direction, it brings us back to 2 pi over 3 in quadrant 2. All right, go ahead and pause the video and see if you can find some coordinates that are in the same location as 4 pi over 4. Okay, so again, to find coordinates that have a positive r value, again, just find coterminal angles to pi over 4. So 9 pi over 4 would work, and so would negative 7 pi over 4. To find coordinates that have a negative r value, we'd have to find the angle that's in the opposite direction. So the exact opposite of pi over 4 is 5 pi over 4, or we could also write that as negative 3 pi over 4. And then again, both of these have a negative r value, which would bring us back in the direction of pi over 4. Okay, so now we're going to work on converting between polar and rectangular coordinates. So we're going to learn how to go from one to the other in both directions. So here we're going to start by finding the polar coordinate for the point that has the rectangular coordinate 2, negative 2. So I think for these it's really helpful to sketch a picture. So we know that 2, negative 2 is somewhere down here. And we know that when we are given this coordinate, well, we could turn it into a right triangle, and we know that it just means this distance is positive 2 and this distance is negative 2. So we know that to create a polar coordinate, we need to know two things. The first thing that we need to know is actually that r value, which is this distance from the center to the coordinate. So this r value can be found by simply doing Pythagorean theorem. So r equals the square root of 2 squared plus negative 2 squared, which is the square root of 8, or 2 root 2. Then the other thing that we need to write something as a polar coordinate is this angle. So we can draw in this angle. Again, we can kind of use this as a reference angle. And then given the information we have, we can create this equation. We know that the tangent of that angle in the picture is going to be negative 2 over 2. So the tangent of that angle is going to be negative 1. So we can actually solve for that using our inverse trig function. And here we know that it would be negative pi over 4. So when you're doing these problems, the last thing to check for is that the angle that your inverse function tells you actually works for the angle you're trying to achieve. So actually, negative pi over 4 could work here. And another way that we could write this angle is moving in the positive direction, which would be 7 pi over 4. So again, that's a coterminal angle with negative pi over 4. So we could write this coordinate in two different ways. We could say 2 root 2 negative pi over 4, or we could say 2 root 2 7 pi over 4. Of course, we could also write this an infinite number of ways. We could maybe have a negative r value, or we could find other coterminal angles for these. But again, just remember, to find a polar coordinate, all you essentially need is the hypotenuse, and then to find the angle to get to that line. Okay, go ahead and pause the video and see if you can give this one a try. Okay, let's check our answers. So here I drew out the little picture. So here we can find our r value again by doing the Pythagorean theorem, and it ends up being 7 root 2. Now here, when I set up my equation, this angle that we found is pi over 4. However, if you notice, this line, or where a coordinate is actually in quadrant 3. So while, arctangent can only tell us this, we have to use a little bit of critical thinking, and we have to make sure to place it in the correct quadrant. So we could do 4 pi over 4 plus pi over 4, which gives us 5 pi over 4. And of course, you could also write 5 pi over 4 as a negative 3 pi over 4 as well. Either answer is perfectly correct. Okay, so now we're going to do the exact opposite. We're going to go from a polar coordinate for 2 pi over 3 to a rectangular coordinate. So remember, when we are given the polar coordinate for 2 pi over 3, that simply means that we have this angle right here. This is 2 pi over 3, and we know that the length of this line is 4. So just like anything else, we are going to turn this into a nice right triangle. And if this is 2 pi over 3, that means our reference angle right here, theta, is pi over 3. So again, that's our little reference angle. Okay, so now to find a rectangular coordinate, we're going to need to know this value, which would be our x value, and this value, which is our y value. And we can find both of those using a simple trig ratio. So again, the angle here that we are working with is pi over 3. So let's start by trying to find x. Well, we know that we can find x by using a cosine ratio. So we could say cosine of theta equals x over 4. So x equals 4 cosine of theta, which in this case is pi over 3. And the cosine of pi over 3 is 1/2, so that means that x is equal to 2. However, we need to be careful because it is moving in the negative direction, so we'll adjust it for that. Alternatively, instead of drawing a picture and using the reference angle, we could actually use the original angle for cosine of 2 pi over 3, and then it will adjust for the negative for you. But again, it just depends on whether you want to think of it as a picture, or you actually want to use the full angle rather than the reference angle. So then to find y, I see that we can create a sine ratio. So again, sine of our angle equals y over 4, opposite over hypotenuse. And then we can solve for y. So y equals 4 times the sine of our angle, which is pi over 3. So y equals 4 times root 3 over 2. So that means that y equals 2 root 3. And again, here you can look at your picture to make sure the sign is positive. We are moving up, so it should be a positive value. And again, if you used 2 pi over 3 instead of its reference angle, it would still be positive because sine is positive in quadrant 2. So our rectangular coordinate would be negative 2 root 3. Okay, go ahead and pause the video and see if you can give this one a try. Okay, so check here. If you sketch out the polar point negative 4, 5 pi over 2, it's the same as the point negative 4 pi over 2. It's coterminal. So here's pi over 2, and then we're gonna head 4 units in the negative direction. So you can see it's actually on what would be our y-axis if we're doing a rectangular coordinate. So this is actually at 0, negative 4. So this one you can tell just by sketching a picture. You don't even need to make a right triangle. Okay, so here are some generalized relationships between polar and rectangular coordinates. So this is kind of just taking what we did by, just using simple trigonometry and kind of turning it into little formulas. So essentially, to go from rectangular to polar, what we did was we found the r value, again, just by simply doing the Pythagorean theorem. So r equals the square root of x squared plus y squared. And we found the angle by using our inverse tangent function. So again, this was all stuff that we were able to do with just our knowledge of trigonometry. You don't have to memorize these formulas, but this is a general formula that you can use. And then for polar to rectangular, we might have noticed that what we did to find the x value is we ended up doing r cosine of theta, and to find the y value, it was r sine of theta. So again, you don't need to know these formulas necessarily to do this, because if you just sketch a right triangle, you'll get the same things. These are just really SOHCAHTOA ratios, but they do exist, and it might save you a little bit of time instead of every single time having to draw out your triangles. But I think that it's more important to understand where these formulas come from rather than just telling you the formula and using them. Okay, so now we're actually going to work on converting entire equations. So we'll start by converting rectangular equations to polar equations. This is a little bit easier than the opposite. So we'll start with this. So it's pretty simple. You're essentially going to take all of your x values and replace them with r cosine of theta. Because as we just saw in the previous slide, that was how we found the x value of our rectangular coordinate. And then you're going to find all of the y values and replace it with r sine of theta. That's all you need to do, and then you just solve for r to make the equation. Okay, so here we have the equation x squared equals 4y, and we'd like to write it in polar form. So again, I'm going to replace all of my x's with r cosine of theta. So I replace it like this, and you replace your y value with r sine of theta. And now we are going to try to isolate r. So this actually becomes r squared cosine squared theta equals 4r sine theta. So you'll notice we have r squared and r, so I can actually divide both sides by r. And then since I'm trying to isolate r, we can also divide both sides by cosine squared. So it equals 4 times the sine of theta over cosine squared of theta. And then we could just simplify this a little bit. You'll notice here we can write this as sine over cosine times 1 over cosine. So we can write this as 4 times the tangent of theta times the secant of theta. So instead of having a ratio of trig functions, we have just simple product of trig functions. Okay, so go ahead and pause the video and see if you can express these two equations in polar form. Okay, so again, replace every x you see with r cosine theta and then solve for r, so you get r equals secant of theta. Here, you have to be a little bit more careful when you substitute for r, or for x with r cosine theta. Again, make sure you're squaring the whole thing so it becomes r squared cosine squared. And same for the y value, it becomes r squared sine squared. So then you'll notice you can factor out the r squared, and then hopefully you remember that sine squared plus cosine squared is equal to 1. So we get r squared equals 9, which means r equals 3. So this does make sense. This is an equation of a circle whose center is at the origin and whose radius is 3. And this is just a radius of 3, which would make a circle. Okay, so now we're going to do the opposite. We're going to convert polar equations to rectangular equations. So this one is not as straightforward. You kind of have to be more strategic, and it will depend on the problem to see what you are going to try. So here's just a list of things you can try. So look for the phrase r cosine of theta, and if you ever see that, you can replace it with an x. Also look for the phrase r sine of theta, and you can replace that with a y. If you ever see r squared, you can replace it with x squared plus y squared. So it could be beneficial to try to create r squared. And sometimes in order to achieve that, you may need to multiply both sides by r. That's a common strategy. Or you may also need to try squaring both sides. Okay, so let's look at this first example together. So here we have r equals 5 secant of theta. So we don't see any of those things we listed in the last slide. So let's see if maybe we could rewrite something to make it a little bit easier. Hopefully we remember that secant is 1 over cosine. So if I multiply both sides of our equation by cosine, we get this. And remember, anytime we see r cosine of theta, we can replace it with 5. And there you have it. Okay, so in example B, again, I don't see any of the things listed on the previous slide. And here, I don't really want to divide by sign because we don't want r over sign. So I look and I think, well, it'd be really nice if this said r squared because I could replace it with x squared plus y squared. It would also be really nice if this said r sine theta because I could replace it with y. So we can actually make that happen by multiplying both sides of our equation by r. So that would give us r squared equals 2r sine theta. So again, anytime you see r squared, you can replace it with x squared plus y squared. And anytime you see r sine theta, you can replace it with a y. So here we do have a rectangular form. It will be nice for us to write this in a standard form. So here's a little reminder of how we can do this. We're going to group everything to the same side. And here we need to complete the square. So if we do negative 2 divided by 2 and then we square it, we get plus 1. So we are going to add a 1 to each side. So x squared, that's already fine. Now if you factor out this, you end up with y minus 1 squared equals 1. And then this would be the standard form of this equation. So remember, this is just a circle with a center at 0, 1, 0 from this, 1 from this, that has a radius of 1. So hopefully you remember this form for a circle. So again, your center would be at HK, and remember this value is r squared. So we do want to make sure our equation is in standard form as much as we can. Okay, so now let's try this last example together. So kind of same idea as last time. It would be nice if this were r squared. It'd be nice if this is r cosine of theta. So we can multiply everything by r. But notice when we do that, this does become 2r. So we will have to deal with that later on in the problem. Okay, so far that has been a little bit helpful because we can rewrite both of these things. So we can rewrite this as x squared plus y squared. Again, this is still 2r, and then we can replace r cosine of theta with x. So now we still have to deal with the fact that we still have an r in our equation, so it's not fully in rectangular form. So what we're going to have to do here is we are actually going to have to try to create r squared. However, I don't want to multiply both sides by r because it kind of undoes what we just did. So we are going to be squaring both sides in order to do that. But first, let's move this to the other side. So we can do x squared minus 2x plus y squared equals 2r. And again, this time we're going to square both sides to create r squared. Again, it would not be helpful for us to multiply both sides by r. So the left side of the equation, it does look a little bit funky, but we can actually just leave it like this. And then here, this becomes 2r squared, which we know that whenever we see r squared, we can actually replace it with x squared plus y squared. And for this case, we can actually leave this as our final answer. All right, go ahead and pause the video and see if you can give these last two problems a try on your own. Okay, so for the first problem, if by simply multiplying both sides by r, we're able to create r squared, which is good, and r sine of theta, which is good. So this becomes x squared y squared, this becomes y. And then, of course, to put it into standard form, we could subtract 4y and then complete the square, and then this would factor. So again, this is a circle with the center at 0, 2, and a radius of 2. For part B, this is like the last example we did. First, start by multiplying both sides by r. So we're able to change r squared and r cosine of theta, but we still have this r value here. So if we isolate this term, we can square both sides, allowing us to remove r squared. Okay, so that is all for today's video. Thank you so much for watching.